from Waits, and his talk will be about AI-driven automation and decision-making.
Thank
Stage
you.
is yours.
Thank you, thank you. Well, good morning, and thank you for attending my session that early in the morning. Today, I'd like to talk to you about a topic which is, has many different type of, let's say, many different type of aspects. Some are technological, some pertain to open source, some pertain specifically to AI. And some really are all about the relations that we have with AI, because a lot of what we talk about when we talk about AI can only be explained if you put this back into the context of the relation that we have as humans with AI. So I'm going to start by saying something that some of you certainly know, some of you might not know. When people talk about AI these days, most of the times they talk about generative AI. But here's the thing, generative AI is only one type of AI, and also it is the result of a very long debate and field and research work that has started, well, really in the early 50s. And without me basically making an entire story of AI, let me just say this. At first, there were really two schools, and there's still somewhat two schools in some regard. There's what we call the school that basically gave way to machine learning and neuronal networks. That's one school, and that's the one you hear a lot these days. And then there's the school of symbolic AI. And symbolic AI is known under a different name these days. It's called expert systems. So basically, one is basically saying, well, we're not going to, we don't even know how the brain works. So what we're going to do is that we're going to generate mechanisms for a system to learn. And by learning, we're going to basically send bazillion photos of cats. And then the system will know how to recognize a cat. Does it understand what a cat is? No. But it can recognize a cat. The other one takes a much more ambitious approach, and in fact it has failed. Well, it has failed. It has failed so far at becoming let's say, the most spoken system of AI, which is the symbolic AI. Symbolic AI will actually try to attempt to have a system understand what a cat is. It's kind of complex, but of course it cannot do so. But expert systems can, quote unquote, think, reason, because they've been taught how to reason to some degree on a very specific set of problems and a very reduced data set. That's also the other difference. But that's the last time I'm talking about that. When we talk about generative AI, in fact, we don't only talk about machine learning. We talk about machine learning because it is at the foundation of what it is we're talking about and how generative AI, a large language model, works. But because a large language model is going to actually take a massive, more or less important data set. And basically, it will work with that data, if you will. There is another approach to this. It's what we call predictive AI. Now, predictive AI has one big difference with generative AI. It can use data sets that are very big, data sets that are very small, and one does not exclude the other. But the one thing it's going to have is that the way it's going to operate is completely different. In a nutshell, large language models are statistical. They're stochastical. They basically going to assume that their answer is going to be based on a number of statistical assumptions, and then they will deliver an answer when prompted in a certain way. That's what we call a stochastical approach. Predictive AI is completely different. Predictive AI relies on the theory of chaos. It sounds like I'm going to tell you about heavy metal, but I'm not. Really what happens is chaos theory is if you don't give me any information about a system or something, it's chaos. I'm just going to assume that anything can happen, anything goes, any data, any values, anything. If you start by inserting one rule, then you are reducing chaos. If you continue with a second and a third and a fourth rule, all of a sudden you start to have a much more predictive system. To give you a very stupid yet very telling example of what it is we're talking about. With a generative AI model, not properly trained, okay, but still fundamentally you're going to have that error. I'm going to submit you a problem. It's a very real problem and it's based on facts. Ever since the Olympic Games have restarted at the end of the 19th century, what happened was we discovered that every 4 years, when we are tracking the performance of sportsmen who race, they sprint race, so they do the challenge of who basically can run the fastest. Every 4 years, the human performance during those races improves. It doesn't improve linearly, but it improves. Somehow it improves. And it has been noticed that has been the case every 4 years at every new Olympic Games with every one of that specific type of contest. Well, based on that constatation, we can of course all agree that we can predict that with a precision of 4 or 8 years, we can predict when human will go faster than the speed of sound. Of course, right? That's a purely statistical approach. And of course, it does not make sense. Yet, this is what LLMs will do. Because they do not have a proper set of rules. A predictive model will actually never do this because it will have the rule of, okay, here are basic human constraints. So we're not going to have that discussion. I'm not saying one is better than the other, mark my words. All I'm saying is it is different. It is different. One does not mutually exclude the other. And basically, you end up with a notion that prompting is not the entire story. You basically can prompt generative AI, you can have a prompt-based generative AI system, and you can still interface it with predictive systems that are data-driven, and you're going to basically only prompt the whole system just to make sure you can access specific options or commands or make specific queries. But the predictive system will basically be able to track the systems that you're managing or that you're overseeing in one way, shape, or another. And the predictive system basically will be expert at detecting anomalies, detecting incidents, manage predictive scaling, and forecast maintenance operations. So in another way, what I would like to say here is that, remember, we talk to AI, but we rarely talk with it. And this is, I think, a major difference or issue that is often overlooked. Now, what would predictive AI mean in IT operations? Now, before I continue on that slide, I will tell you, of course, predictive-based software or software with predictive operations is not new. We had that for quite several years. You can basically have an entire set of rules. You don't call this AI. You have rules, you have data streams that's coming from specific data source inside a system, and it informs you, it informs the system that certain things are happening or not happening, and based on that, the system can predict, can analyze, and can react to a certain extent. If you have an incident, for instance, and it can alert you, it can do other things. So, with a predictive system, with a predictive AI system, what you add is a true autonomous adjustment. The true autonomous adjustment isn't just, oh, based on these rules, I have to do this or I have to alert X, Y, and Z. What you can do is add a layer of intelligence, basically. So the system is starting to become a bit more autonomous, basically. It can basically as an example, predict when a certain number of hard drives will fail. It can forecast resource allocation for specific clusters. And of course, it can drive the cybersecurity incidents management, detection, and prediction based on the data that you can feed it. So this is quite interesting just for that. But what would, perhaps in more detail, what would an AI-based automation system look like? What would it do? Well, you of course start with data sources, and based on this data source, you have the feature extraction, and then you have your predictive model, which is not, again, a large language model. The large language model comes over it, and the way it comes over it is that you basically take from the data source, you basically take the same data and you add to it a policy layer, and you have a decision engine. That decision engine is basically, I would say, the combination of the predictive system and the generative AI large language model. In the end, what you get is automation that works as a closed loop. Because instead of being fed constantly external data, for instance, from humans, what you have is a system that looks at itself in some way, shape, or form. But of course, and this is something we talked about yesterday at the round table, it is very important to still have human in the loop, to keep them in the loop, so that they can basically act as guardians or custodians or checkpoints of the entire systems. And you need more humans as the system becomes more critical, of course. But at the end of the day, what I would like to say here is, from a pure openness perspective, what you can end up with this is a systems that provides visibility, traceability, feedback, transparency, and what you do not end up with is a black box, which is exactly what we want to avoid. We want to avoid this for the sake of software freedom. We want to avoid this for the sake of openness, and we want to avoid this for the sake of security. We want to absolutely avoid that. Black boxes never are a good idea. And because of that, let me give you an example of, what could be the potential of the open source ecosystem if it were to be applied to these type of things. So basically, you would have predictive pipelines that would have Prometheus with MLflow and K-serve. That's one example. But what you would get here is the K-linearity engine. You never heard about it. It's actually proprietary at this point. But this one, it would be the predictive one. And then you have shared data sets, reproducible models. And what you basically end up with is a world, which is the world that we have more or less today, which is closed AI systems. Because not a lot of what you have in terms of large language models are truly open source. It's not true. So you basically have a closed world, more or less closed world. But based on that, if we carry on to actually insisting on having open predictive systems and basically an AI-based automation that is open and responsible, you end up having an open predictive fabric. And it's the fabric of what? It's the fabric of automation and management of infrastructure. This is really what it is about. Based on that, you can elaborate an actual governance. You can actually think about having a proper discussion about interoperability, transparency. You can mandate all of these while being granular and while actually making sense. From a point of view of the regulation as it stands today, we have the upcoming European Artificial Intelligence Act, AI Act. That act will require transparency. It will basically require transparency not just on the code, it will require transparency on the weights, it will require transparency on the data sets and the models, at least to some extent. This is something which will be very important because it will at least provide a large degree of transparency. At least that's what we hope for. Having said that, we do have certain challenges that are facing us. which is that once we have all this, it sounds quite good, but we're going to have to deal with data fragmentation. We're going to have to deal with the fact that at the end of the day, none of these systems are perfect. Some of them, as we say, hallucinate, or at the very least, they drift. They are biased because they can be biased. They can even be trained to be biased. So that's a problem. And then there's going to be more and more barriers of entry for anyone who would like to innovate, or for anyone who would like to actually come up with or be equipped with these kind of software, because they will become, the barriers will become higher, and the prices of acquisition of these solutions will also become higher. So you're going to have an accessibility problem in terms of resources and what is being offered. And of course, at the end of the day, how do you measure trust? How do you set accountability? All of that is not set at this stage. In practice, we're going to have an issue which already exists today, which is having, what's the quality of the data I'm collecting? What am I measuring? So what is the telemetry? What does it do? Just to give you an example, we can do basic telemetry when it comes to measuring the network load, the CPU load. Okay, that's something we can do on a server. But did you know that in order, even on standard servers, in order for you to actually come up with proper telemetry, you need to have proper drivers and access to proper code for a lot of OEM manufacturers. And all of them are going to be a bit different from the others if you want to be more granular. So in so many respects, you can take the most established vendors today that do not come across as being proprietary in the sense that, well, they're servers, they're x86 servers, everything's fine. Well, you're going to have access to their own documentation. You're going to have to talk to them. You're going to have agreements so that you can access the proper telemetry for each of their servers, because each of their server types are going to have a specific ways to handle things. And in order to have a good quality, in order to have a good telemetry, you're going to have to work with these guys, with these companies. So it's not, we don't just plug something on a system and it's going to happen. What you're going to have is standard data, but you're not going to have a high quality in terms of data. And then, of course, you're going to have the observability problem, which is, of course, that you need to define the right rules. And if you want to get the right information, you need to pay attention to the fact that, well, at the end of the day, I understand that you want to see certain things, but be careful that your own rules are not making you biased. And there's not one scenario per all the customers. All the customers are going to have, many customers are going to have at least specific constraints, let's say. So at the end of the day, I talked to you a little bit about some, the short history of AI. One of the big conversations is, and we had that yesterday during the roundtable, is AI going to overtake the jobs of, the engineers, this and that? I don't think so. I don't know. I'm not an oracle, but having said that, what I can see, what I can sense, is that today's discourse on AI is dominated by two things. Fear of losing one job, fear of having a world that you no longer recognize, that has become entirely robotized for no sense, and greed. If I had my startup in AI, I would make bazillions of euro, dollars, and I would go there and I would have Ferraris, and et cetera, et cetera. Now, I think, of course, obviously, those two extremes are radical and they're extremes, that's what they are. But let me propose to you a third path, which is continuity and presence. So let's define a bit continuity and presence. Because one is something that we can basically handle through technology. The other one has to do with humans. In a nutshell, when it comes to infrastructure management, What I realized is that infrastructure management needs continuity. Continuity is fundamentally about the ability for a system and for its AI instance to be stable across updates, changes, to be resilient, no matter what the type of network, no matter what the type of deployment, and also across the deployment of your organization. That's what you need. You need continuity of that AI model. You need something which is capable of telling you that, yes, it was that way 6 months ago. It changed, but here it kept the records, not just mindless logs. It kept the records. It has a level of, in a sense, a degree of autonomy in understanding what it is about. What you need is, for continuity, is predictive telemetry. What you need is open interfaces and interoperability so you can scale and change across the changes of your organization. And if you do this, then what you have is a system that can basically do or deliver the benefits of predictive AI across VMs, across CPU cycles, that can do anomaly detection, that can basically handle autonomous orchestration, that can be adaptive, and all of this can be open source. Now, that's continuity in a very technical way. So how could I, in fact, define continuity in, let's say, one or few words? Continuity are systems that learn without rupture, while presence is the factor that maintains human oversight and purpose across the systems. In the end, what we get is automation that is not just robotic, senseless automation, but it's automation that stays and remains aligned with those it serves. That's what we need. We need continuity and presence. Now, I'm not going to give you a roadmap, of course, because what I'm talking about here is somewhat perspective. It's not highly perspective, because we're not very far from that. What we need is, of course, to bring predictive AI systems in tool chains of developers and DevOps to basically make them aware that those tools can exist and those tools can be developed. To this day, this is possible. This already exists. We also need to publish more of these predictive models, and we need to publish them as commons, so as open source software, but also as data commons. We need to educate teams, and basically we need to, I think, operate on ourselves, something which I consider is extremely important. We need to go beyond the prompt. We need to partner with systems. We need to understand that one of the key elements of all of this is not prompt as a consumer of a system, but partner with the system. If you basically operate that shift in your mind, you, I think, have shifted your own perception of how AI works. Because you are moving from, again, a consumer-based type of approach. I'm going to prompt this, and if I prompt this a certain way, it will give me the other. Yeah, of course, yeah. But you need to have, and that's a relational approach to the AI. And AI is not a person, of course. We're all quite aware of that. But it's not a bloody operating system. It's not just a Python software. It's not a mobile application. It's something which is a bit different, and contrary to the rest of everything I've mentioned, requires a relational approach. If you do not have that relational approach, you will be stuck in prompting, and you will use it as you would be using a search engine. No less, no more. So, of course, what I'm saying is that once you have that, well, you can't really have that if you don't trust. And trust comes through several factors. It comes through human presence. It comes through openness of the systems. and it comes through the ability for that system to be continuous, to emanate continuity, meaning it's not just a mindless machine, it's something else. It does something else. I'm going to stop there. I'm going to leave you the mic, and I will basically just conclude with one word. I believe the measure of intelligent automation isn't how much it replaces, but how well it sustains continuity. So I don't think the jobs will be that threatened. I think the jobs will be, our jobs in innovation, our ability to create. We can keep that, absolutely. We just need to understand how we can be sustained by AI, not threatened. Thank you.
Thank you very much, Charles. So we have a lot of time for audience questions. I already see the first raised hand. In the first row, please. Yeah, you get the microphone.
I'm not an expert, but still I have a practical question about training and using the systems. Most of the training is done in English. Mm-hmm. All the companies are over there, and it's English words being tokenized and so on. And the training is done in the English language. I am at a disadvantage if I use my system and speak German to it and ask my question into German. And then I have a second question. If I do understand the systems well and what you explained, AlphaGo was an expert system-based system which defeated Lee Sehol, and AlphaZero was the chaotic system. They started from zero, no data, and machines were playing against each other, and it's better than anything ever created and cannot be beaten by humans.
So, about the language. It's interesting. So what you're mentioning is a bit of a head scratcher, because in Italy, don't quote me on this, but I know that what they've done in the private sector, I think, is that they came up with the first full Italian LLM. It's not ChatGPT, they came up with a full Italian LLM. I'm not sure it's open source, it's very proprietary, very innovative, it's rather new, and so they trained it, and then they realized that whether it was speaking English or Italian, it basically had the same performance, if you will. So I don't know if you're at a disadvantage. I would say that it probably depends on the model. It probably depends on the model, but I would also say that if you train yourself the model with your language, provided that it has that capability, it will end up learning and it will be just as performant. On your second question, I think what you're pointing at is a fascinating thing. Because what you've just pointing at is data set does not do everything. In fact, you know, when you deploy, when you have an LLM deployed, the data is stuck. You need to have very specific tools to update the data just to make sure that it's going to continue to be updated and receive more information, because while you're using that LLM, it doesn't really learn from the data. The data is basically dead, it's just set. And so what you've described is a system that can basically learn without being impeded by XYZ petabytes of data.
Thank you. We had a second question here in the front.
My question is predictive AI still an idea on paper, or as of today, I can already implement the pipeline with Prometheus, MLflow, and K-server?
So, does predictive AI systems, do they exist? Yes. They exist because they've existed, in fact, for a long time. Can you implement what I've described? To this day, this remains to be done. We're looking for research funding, but it's not something that is sci-fi. That's what I'm saying. It's going to happen if it hasn't already happened with some other technologies.
Thank you.
Are there some more questions from the audience? No, I have a question as well.
Okay.
I think it's similar to your question. So are there like some promising, especially open source projects that are going in this direction for predictive AI, maybe also related to infrastructure, monitoring, telemetry?
So in terms of infrastructure and telemetry, yes. I mean, you have existing tools. We're mentioning Prometheus, but there are others, and they're getting better and better. There are, I would say, two, if you will, there are two constraints. One is to come up with a predictive system that is truly open source. And, you know, there you're going to have the issue of, well, you're going to have the predictive system, and then you're going to have the algorithm of prediction. And the algorithm of prediction is not necessarily going to be in itself open source, but you're going to have the software that's going to be open source. So you're going to have that dichotomy that you need to pay attention to. So to the best of my knowledge, we're a bit far from that, from having everything open in that regard, but we need to move and continue down that path. The other, the other constraint, and it's the one that I mentioned, is what are you exactly collecting? Because you can be very good in having a proper telemetry management and you know, data representation, but as I said, you're going to be dealing with established manufacturers. I will not name them, but it's pretty much all of them, where you must have some kind of NDA in place, and they can have to give you access to the proper APIs and the proper drivers so that you can have quality in your telemetry. And that's the big problem. That's the other big constraint.
Okay. If there are no questions, then I think we can close it. Thank you again.
Thank you very much.